Good morning, students. In our last class, we have studied about cathode ray experiment and discovery of electrons. Today we will study production of anode rays in the discharge tube and discovery of protons. Goldstone repeated the cathode ray experiment using a perforated cathode. He observed that there was a glow on the wall opposite to that of the anode. So, some rays must be traveling in the direction opposite to that of the cathode rays. That means from the anode to the cathode. These rays were called anode rays. See, these are anode rays. So, anode rays travel from the anode towards the cathode, whereas cathode rays travel from the cathode towards the anode. So these anode rays are also termed as canal rays as they moved through the perforation or canals in the cathode. It was found that these rays contained positively charged particles. So J.J. Thomson called these rays as positive rays. Let us discuss the properties of anode rays or canal rays. Anode rays travel in straight line in a direction opposite to that of the cathode. In the presence of an electric field, anode rays deflect towards the negative electrode. This indicates that the constituent particles of anode rays are positively charged. Anode rays or canal rays are deflected by magnetic field. In the presence of a magnetic field, these anode rays deflect in a way which indicates that these are composed of positively charged particles. Anode rays produce fluorescence when made to fall on zinc sulfide. The charge to mass ratio of the particles constituting anode rays is not fixed like that of the cathode ray. Its value depends upon the gas used in the discharge tube, the highest being for hydrogen. So this is a very important distinction between cathode rays and anode rays. In case of cathode rays, E by M ratio is fixed. It is independent of the gas used. But in case of anode rays, E by M ratio is not fixed and it will change if you change the gas in the discharge tube. We have studied that on applying a very high voltage and low pressure, electrons eject from the cathode in the form of cathode rays. The electrons constituting the cathode rays must come from the atoms of the gas inside the discharge tube. Electrons are negatively charged particles. So, the atoms must be left with an equivalent amount of positive charge. See, this is an atom of a gas. Now, this is A plus electron. Now, it is this positively charged particles that constitute the anode rays. As an electron has a negligible mass, so the particle A plus will have the same mass as that of neutral atom of the gas A. So the value of E by M, that is charge by mass, will differ from gas to gas in case of anode rays. Now these anode rays travel in the form of canal. constituting the positive rays. After the discovery of anode rays or canal rays, attempts were made to discover the lightest particle which carries a unit positive charge. Therefore, the anode rays or the canal rays produced by using various gases were analyzed, and it was found that the lightest positive particle having a unit positive charge could be obtained by using hydrogen gas in the discharge tube. The value of E by M for the constituent particles of this gas was found to be maximum. Why in case of hydrogen gas the value of E by M is maximum? This is because this particle possessed a minimum mass and a unit positive charge. Determination of mass of these particles revealed that the mass of one particle was 1837 times the mass of an electron. This particle was called a proton. This is a neutral hydrogen, H plus electron. This H plus is the anode ray and this electron is the cathode ray. Proton is actually an ionized hydrogen atom and can be represented as H plus. The charge and mass of a proton were determined almost in the same manner as the charge and mass of the electron were determined. The study of these anode rays involving various gases and their E by M measurement of proton showed that proton is the lightest positive particle found in atomic beams in the discharge tube. Protons were also obtained in various nuclear reactions. Hence, it was thought that proton is a subatomic particle and is present in all atoms. Since the positive charge on a proton is exactly equal in magnitude to the negative charge of an electron, a neutral atom possesses the same number of protons as is the number of electrons present in it. So how can we define a proton? A proton is a subatomic particle which has a mass equal to 1.672 into 10 to the power minus 24 gram and a positive charge equal to 1.6 into 10 to the power minus 19 coulombs, that is 1 unit charge. So this much for today. In our next class, we will study about the different atomic models. Thank you.